Okay, for each of the following function H, determine whether there is a constant C greater than zero such that function P of S equal to C H of S defines a probability mass function PMF over the given support X. If such a C exists, find it. Otherwise, explain why it does not exist. Of course, earlier in the week, I walked you through different ways of identifying probability model. Okay, I remember I talked about probability mass function, probability density function, and cumulative distribution function. So when I talk about probability mass function, probability mass function is a probability distribution of a discrete random variable. Okay, so for instance, if you, how are you going to know? How are you going to identify probability distribution of a random variable? Of course, I told you the other time about the probability, the Kolmogorov axioms. The Kolmogorov axioms, like number one, I talk about non-negativity. Number two, I talk about normalization. Number three, I talk about additivity. Now, you are given A to F, okay? They give you identity function on the set. We normally call this support. Okay, this is a support 0, 1, 2, negative 2, 2, 2. They will call them support. So they wanted to figure out what the values of C is going to be in such a way that C multiplied by H of L defines a probability mass function. They wanted to do that for identity function. When this is the support, they wanted to do it for a constant function. When this is support, they wanted to do it for quadratic, they wanted to do it for cubic. Okay, so I need you to pay attention. So if I actually want to start the first one. Okay, so I'm gonna basically explain what I'm actually doing here. Okay, I'm gonna explain what I'm doing here. Now I got this as the support. Okay, if that guy is the support, because they told me a cost, identity function, remember in class, identity function is going to be that. So, situation where, um, you know, the output is the same as the input. That's an identity function. That's a perfect preservation. Okay, so now if I want to, so which means the h of s, okay, for if x equal to, 0, first equal to 0, 1, 2 given, then my h of s also going to be the same because of the fact that we said it's an identity. So if we now want to do the product, don't forget, based on what they asked you to do, they wanted to do the product. They said, uh, we want to figure out what's the P of S it got to be. So what I'm gonna do is, you want to multiply H of S, okay? You want to multiply by C, and then after multiplying by C, you're actually going to sum them out. When you sum them out, they have to be equal to 1. Okay, so now it's going to be, 0 multiplied by C plus 1 multiplied by C plus 2 multiplied by C, and all it's going to be equal to 1. Okay, so when you solve that, you're going to have a 3C equal to 1, and what you are going to have finally is going to be C equal to 1 over 3, and that was how I got 1 over 3 here. So is there anybody else, there anyone who need clarification on how I figured this out? If you understand what I just explained, I need you to say yes, or you comment yes if you understand what I just explained.
Yeah, that's
Okay,
clear.
okay, thank you so much. Thank you for confirming that.
Mhm.
Okay, so that is how that is going to be done. Let me say this is being recorded. I'm also gonna, and I've started sharing my recordings on YouTube, my YouTube channel. Okay, those of you that reply, thank you so much. That reply yes, thank you so much. Okay, so let's go to the second question. Now you're gonna do the second question the same way. Okay, you're gonna do it the same way. Okay, you know, you know, being, having a constant function, you're still gonna have all of these. But let me tell you this: if you sum them, if you sum the HS, okay, you're actually gonna see that's gonna be zero. A situation which means you may not be able to find your C. Okay, C is going to disappear. When C disappear, then it means that cannot be normalized. So which means a PMF, a probability mass function, does not exist in that situation. Okay? So that's exactly what we mean here. Now I'm quickly going to move to another question C. We take a look at question C right now. It said for whatever the values of input, the output is always going to be one. Okay, this is what that is what this guy is trying to talk about. Give me 1 second. Okay, so that is what this guy is trying to talk about. Okay, whatever the values of that's which actually means is a constant function. Okay, so if it is a constant function, okay, so when s equal to 0, h of s is going to be equal to 1. So when s equal to 1, h of s is going to be 1. When s equal to 2, h of s is going to be, 1. So they're all going to be 1. So if I multiply them by c, 0 multiplied by c, okay, sorry, give me 1 second. So if I multiply 1 by c, because it's going to be 1 in our situation, 1 by c plus another 1 by c plus another 1 by c, then I equate it to 1. Okay, so I multiply 1 by c because the output is always going to be 1 irrespective of the input. I'm actually going to have a 3c here equal to 1, and 3c equal to 1, where we imply cell c equal to 1 over 3, and that was wow. I got 1 over 3 or here. Okay, so in case if there's anyone who doesn't understand, please make sure you ask a question, and that is how that very day, that's how it is done. Okay, so I'm actually gonna move to the part right now. I'm gonna move to the part right now. Now, when you take a look at the deep part, we see have a constant function. Okay, now when you take a look at what I have here, a constant function 1 for every input, so which is going to imply I'm actually going to have 1c, another 1c, another 1c, another 1c, another 1c, then that will be equal to 1. And of course, I'm going to have 5c equal to 1, and that actually imply my c to be 1 over 5. Okay, that was how I got 1 over 5, which means the probability mass function exists here when C equal to 1 over 5. So we're trying to figure out when the probability exists, for any given scenario. Okay, so if that is taken, I'm going to move right now to the next question. Okay, now I want to move to question E. Now, we're having a quadratic function now. So you're mapping from X. Okay, so this is a typical situation. Okay, it's a typical situation where you are actually doing the mapping from S to S squared. Okay, so in this regard, okay, h of s equal to s squared. So here there's going to be transformation here. Okay, when s equal to 0, so I'm actually going to have 0 squared. Okay, I'm going to have 1 squared. I'm actually going to have 2 squared. And don't forget, I'm going to multiply h by c. Okay, I'm going to multiply h by c. then I'm going to equate to 1. So don't forget, based on what you're giving. Okay, so what do I have right now? Okay, if the zero cancel out, okay, 1 square C, 2 square C, that is automatically going to give you 5C equal to 1. Okay, if you have 5C equal to 1, 5C equal to 1 when you solve for C, you're actually going to have 1 over 5. Okay, so that is how to do about that. Okay, the transformation is actually involved here. Okay, so is that is taken now. So I'm gonna go to the next question. Okay, the next question is also talking about quadratic. Okay, except that we have a different support. This time around, we got support from -2. Oh, to 2. So, and of course, you're still doing the transformation of inputs, okay, into a squared. Okay, so, and that's why when you're trying to, what I was trying to do here, okay, is if I have this as x, okay, squaring that, okay, squaring that, I'm actually going to have that guy. And the moment I have that guy, then I start multiplying each of them by c. You can even add them up and multiply by c, okay? So I'm actually going to do 4 plus 1 plus 0 plus 1 plus 4, then multiply them by c, then equate it to equal to 1. And of course, when I do that, I'm actually going to have 10c equal to 1, and that implies 1 over 10. So that was why I got 1 over 10. So which means the situation under which the probability mass function is going to exist is when c equal to 1 over 10 based on this transformation. Okay, so that's how we do that. Okay, so I'm gonna go to the next question now. Like I said, every Friday, what I'm gonna be walking us through, it's gonna be a worksheet from what we've done before. Okay, what we've done in a week. Now I need you to pay attention to what we have right now. Okay, so when you pay attention to what we have right now, okay, you have another transformation taking place. Okay, so the transformation taking place is actually, you want to map from X. Okay, you want to map from X to C. Okay, now if you want to map from X to C, this time around, you actually having X. You want to map, from X into, give me 1 second. I'm gonna see what. Okay, let me take my down again and clean that up. Okay, then now you want to map from X to SQ. Okay, and you know what? You have this guy as support. Your support is 0, 1, 2, right? Now when you have 0, 1, 2, okay, so this is gonna be 0 raised to power 3 plus 1 raised to power 3 plus 2 raised to power 3. Okay, and don't forget you're gonna multiply by c or equal to 1. So when you take a look at that, that would be 0, 1, 8, which is what I have here. So I'm gonna add 0 to 1 to 8. Okay, then when I do that, so I'm actually giving 9c equal to 1. And when you solve for c, automatically that will give you 1 over 9. Okay, so that is how that is done. Okay, so make sure that you understand you can be giving any kind of function. Okay, when they give you any kind of function, of course they're gonna ask you to figure out the values of c, whether it exists or not. Okay, they want to figure that out such a way that it's gonna be the probability mass function is gonna be defined. Okay, that's how question number 1 in the worksheet is actually done. Now, I want to move to question number 2, and I want to confirm again
If everyone is still hearing me clearly. Is everyone still hearing me clearly?
Yep.
Okay, thank you so much.
Yes.
Thank you so much.
Yep.
Thank you for confirming that. Now, I want to walk into question number two right now. Okay, I want to go into question number two right now. Now, determine the set of real numbers, theta, such that, f of s, theta f of s equal theta when s equal to x1, theta square when s equal to s2, and 1 minus theta minus theta square when s equal to x3. Okay, is a PMF on the sample space. Now, you've been told right now, if you take a look at this question now, you've been told that it's a PMF. You know what PMF means? The PMF means probability mass function. So, what you actually need to do, is to investigate whether the Kolmogorov axioms hold. Now, because it's trying to tell you each of these is a probability, okay? Because f of s is a probability, so which means we expect theta to obey Kolmogorov axioms. We also expect
So theta squared to obey, we expect 1 minus theta squared to obey that. Now, if we go by what I provide here, okay, what did I do as number one? Okay, don't forget in class I talk about the Kolmogorov axioms for any probability function, whether probability mass function or probability density function, any probability function at all should obey Kolmogorov axioms. Now we're gonna first investigate the Kolmogorov axioms, the Kolmogorov axioms of non-negativity. Okay, now we have to say that, the theta has to be greater or equal to zero, and theta squared has to be greater or equal to zero, and the other one also have to be greater or equal to zero. There is something that we know very sure out of these three, out of this one, and this one. It is the second one that we know is always going to be true. Because theta squared, when I have theta squared, whatever values of theta, of course, theta squared is always going to be greater or equal to zero. But we're not too sure now of the second and the third one. And that is why we need to solve for theta as time goes on. We need to be able to solve for theta, okay, so that we can actually see. Now, the first one, like I said, is a non-negativity, okay? We're posing that, from Kolmogorov, from Kolmogorov axioms. Now, another, since they call that probability, okay, since they call that probability, we expect that when I add all of this one together, it must be equal to 1. You remember in class, I told you the probability of the sample space has to be equal to 1. Okay, if I'm talking about PMF, I'm talking about probability mass function, okay, then I mean I'm focusing on the discrete random variable, and I'm expecting the sum, okay, the sum of the probability, okay, the sum of the probability has to be equal to 1. Okay, so now you need to investigate that. When I had theta to theta squared, when or to that, do I have 1? Okay, yes, I have 1. If you take a look at that, adding them up, it's going to give you 1. Okay, so adding them on, if adding them on give you 1, then you're actually saying the normalization hold, which is exactly what I'm doing here. Okay, give me 1 second. It's exactly what I'm doing here. Okay, I'm actually, sum to 1 actually means normalization. Okay, the normalization property, okay, of the Kolmogorov axioms. Okay, I just wanted to take note of that. So you can see it obey that is sum up to 1 when I had them up. Okay, I then added them up. I give you 1. Okay, now uh, after that, I said something the other time. We will impose a condition on theta. Okay, we want to see we got to figure out what theta mean. You know, if you take a look at, we said that before that, okay, according to the non-negativity condition, the theta will be greater or equal to 0. And of course, we also said, the third probability, okay, 1 minus theta squared have to be greater than equal to 0. Now, do you know we can solve this inequality equation to be able to find the value for theta? Okay, how do we solve this inequality equation? So this is the same thing as this. Okay, when I have a negative theta squared and negative theta, if I multiply both sides by -1, I'm going to have theta squared plus theta minus 1 less or equal to 0. Okay, and of course, if you look at the power here, the leading power, okay, that's quadratic, right? Then I'm actually going to solve this quadratically using quadratic formula. Okay, we're going to solve that using quadratic formula, which is what I'm actually doing here. Take a look at that. That's a quadratic formula, right? Okay, now when you go back into, when you go back, if I want to solve quadratic equation, okay, quadratic equality, okay, I'm actually for so fine when it is equal to 0. And of course, you remember in high school, AS squared plus BS plus C equal to 0. Okay, right now, our x is acting like a theta, so a theta squared, okay, plus b theta, okay, plus c equal to 0. When you compare this with what I have here, so your a is going to be equal to 1, your b actually going to be equal to 1, and your c equal to -1. Okay, so when you have that, so that was exactly what I was referring to. Okay, that was give me 1 second. I'm gonna clean up right now. Okay, that was what I was actually referring to here. Okay, A equal to 1, B equal to 1, C equal to -1. Then this is the quadratic formula that I'm going to plug them in. When I plug them in, I got my theta equal to that. But don't forget, we don't want a negative theta. We want a positive theta, because we said theta have to be greater or equal to 0. So, I have two roots. Solving quadratic equation. This is going to be the negative answer. This is the positive one. So we're going to be interested in the positive one. So we're going to nullify the negative one. So at the end of the day, we're actually going to impose, we're going to say our result at the end of the day is this. So we're going to assume the one for the negative. We're going to assume it to be 0. Because we want our theta. If you take a look at what I actually have here, okay, I'm actually saying my theta has to be greater or equal to 0, and of course theta less or equal to square root of root 5 minus 1 divided by 2. That is exactly how. So we're actually telling the world right now the set of real numbers, for theta, that will make, the f of s, the probability of mass function, okay, it should be this. So that's exactly what we mean. Okay, so which means we're going back, applying the knowledge of quadratic function equation, that you did in the high school. Now I'm actually gonna move to the next question now. Give me 1 second. I'm gonna move to the next question. Okay, I'm gonna move to the next question. Now, the next question was centered on, you know, relative difference, symmetrical difference, and I need everyone to pay attention now. So I need I need everyone to pay attention now. So now, what I'm, in class, we actually did. Uh,
What has relative difference, the symmetrical difference. So I needed to pay attention to this right now. Okay, so if you take a look at what I have, if A equal to 1 to 8 and B equal to 1, 3, 5, 6, 7, 8, 9, then what is A minus B? A minus B is the same, is what we call A relative B, which means you want to figure out, the element that are in A that are not in B. Okay, Now, the element that are in A that are not in B, so take a look at these, 2 and 4. The 2 and 4 are in A, but they are not in this B. And that was why we said it's going to be 2, comma, 4. Okay, so A minus B means elements in A, but not in B. That's what we mean. Okay, and of course, if you want to go by B minus A, okay, the B minus A is going to say, what are the elements in B that are not in A? The element in B, not in A, is actually 9. Okay, as you can see that. And the moment you have your A relative B and B relative A, and somebody asks you to find, that is what we call symmetric difference. So the symmetric difference, I need you to pay attention now. The symmetrical difference is the union between A difference B and B difference A. Okay, now you get 2 and 4 for A difference B, you get 9 for B difference A. The union is bringing all of them together. Okay, the union is bringing all of them together, and that will give you A difference, asymmetric B. So asymmetric, okay, B actually means the union of A difference B and B difference A. Is there any question here? Is there any question here? Okay, if there's no question here, I'm actually gonna move. Okay, so that is how we do, that's how that is done. Okay, so which means you will be able to do question 2 and question 3. At times you may be given alphabet. It's not all the time. Set is not only numbers, set can be object, can be whatever, can be in words. Okay, now you take a look at question number 3 here. Now we have a P to be that, Q to be that, and they wanted to figure out P symmetric. So if I were you, what you need to first do, what is your P difference Q? Okay, then what is Q difference P? And after you're done with that, then you're gonna find the union. Okay, you're gonna find the union of that. So the union of that is what this guy is equal to. Okay, the union of that is what that guy is equal to. Okay, now if you apply the same approach here, you can also apply that for situation where you have words. Okay, now I'm gonna walk you to number 4 now because I know question 1, 2, 3 here they are related. So you can use the same strategy for number 1, for number 2, and for number 3. So I want to go into question number 4. Okay, now you are given ABC. You're given set ABC. Okay, you're given the set ABC to take a look at what you have. You're given set ABC, right? And of course, they wanted to figure out A union B. Okay, so how do I figure out A union B? Okay, I needed to pay attention now. Okay, how do I figure out A union B? Is just combining elements in both. Okay, combining elements in both, that's going to give you a union B. And that was why I have what I have here. Can you see that? I've combined elements in both. Say, that's what union implies. Okay, now the next one now is asking you to find A intersection B. Okay, the A intersection B is, what is the element do they have in common? Okay, the element they have in common, of course, they actually, from what I'm seeing, they have red in common, and that's why I said the intersection D is actually red. Take a look at that. Okay, now I want to come into the third question now. Okay, I want to come into the third question now. I need you to pay attention. Now, I want to find a complement. I need you to pay attention here. I want to find a complement intersection C. Okay, now do you know this is the same thing as C minus A? Do you believe that? Okay, I need you to pay attention now. Okay, A intersection C, I mean A complement C okay, intersections. I mean, complement of A, intersection C. I'm going to say that again. Complement of A, intersection C is the same as C minus A. When I say C minus A, I want to figure out what are the elements that I have in C, okay? The element that I have in C, but not in A. Okay, the element that I have in C, but not in A, okay, like orange, there's orange in C, there's orange here. There's no orange in A, okay. There is yellow in C, there's no yellow in A, okay. There is purple, okay, in C, but there's no purple in A. So, well, the bottom line is whenever you see A complement intersection C, it actually is synonymous with C difference A. That's exactly what we mean. Okay, so that guy is done now. I'm actually going to move to the next one. Now, I need you to pay attention to this situation where you have three different type of set that actually contain words, and they want you to apply. Like if you take a look at the first one, they wanted to do, the H intercept F. Give me 1 second. They wanted to do a H intercept F union W. Now, you can see parentheses on H intercept F. You actually need to start from the parentheses. Okay, you need to first figure out what is your H intercept F. Okay, so your H intercept, this is what I did here. The H intercept F is what is common between H and F. And after I'm done with that, then I'm going to find the union between what I got and that of the W. So which means I'm actually gonna add the dog and rabbit that I got for H intercept F to that of W. So I'm gonna have a lot. That's why you see that. You got a lot right now. You see that? You got a lot right now. Okay. Now, if I want to go for solve the second question, so for the second question, okay, let me take a look at the second question. I'm actually going to do the same. Don't forget, before for start, you do it one at a time. You start with the one in the parentheses. If I'm going to start right now, the one in the parentheses is F union W. I'm going to start with the F union W, so which means I'm going to combine F and W together, and whatever I got, then I'm going to look for the word in the point of intersection between H and F of F union W. So, which is what I have here. You can see when I started finding, what is the F union W, because F union W is actually in the parentheses, and of course, then I'm going to, I'm going to find what is the point of intersection between this guy and H. Okay, so what do they have in common? So, and what they have in common is actually dog, rabbit, and mouse. So take a look at that. Now, I want to go into the third one. When you take a look at the third one, okay, don't forget, take a look at the third one. Okay, you first focus on the one in the parentheses. What I have in the parentheses right now is I got H intercept F, the complement of that. So what I will first do, I need you to pay attention now. What I'm gonna first do, before I do the complement, I first do the H intercept F. Now, the H intercept F right now, okay, the H intercept F, okay, is actually this guy here. So what is common between H and N? Okay, this is the H that I'm talking about. This is F. Okay, so what they have in common? Okay, they got rabbit in common. Okay, there's rabbit here, there's rabbit here, there's a dog here, there's a dog here. Okay, so they actually have rabbit and dog in common. And after that, after getting H intercept F, now I now need to find what is a complement? Okay, what is a complement? After getting this guy now, I also need to find what is a complement of what I just find. Okay, what is a complement of what I just find? Okay, and that was why I said now we need to find so the complement between what and what. Okay, the complement between that and W. Oh my God, which means that guy is trying to say W my symmetric relative difference W minus, okay, W minus H and F. That is what we mean. What are the elements in W that are not in H and F? I'm going to say that again. What are the elements in W that are not in H and F? Do you know why do I say not in H and F? Because the H and F has a complement. The complement actually means not. That's what it means. Okay, that's what I figure out here. Okay, so if you take a look at all what we've done before, so this actually form part of what we did in class this week. Then I'm gonna move. So you can verify this, okay? You can verify this out. When A equal to that, B equal to that, C equal to that, they want to show that A relative difference B union C will be equal to A minus B, that is A relative difference B intersection A relative difference C. So if you want to start, I can start from B union C, right? So the B union C is bringing all of this, together without repetition. Okay, no repetition. I got a -1 here. I got a -1 here. You have to write it once. Okay, so where there's repetition, when you are combining, you're only going to write one. So this is my B union C now. Okay, combining this guy with a guy. Now, what I want to do now is A minus B union C minus B union C. What are the elements? Okay, what are the elements in A that are not in B union C? The elements here that are not in this big union C, okay, like -2, 1, and 3. So that's why. So this actually is for equation 1. That is for the left hand side. Now, if I want to do this, I need to first do what is A minus B. What are the elements in A that are not in B? Okay, what are the elements in A that are not in C? Can you see that? Then I'm now going to find the intersection between them. The intersection is this. Okay, and when you see that, this equal to that. So with that, I've already proved that this equal to that. So I prove it set, with numbers, that. So now that's already proved. Now you remember in class, I on Friday, I talked about De Morgan's law for complementation. Okay, there are two De Morgan's law. The first De Morgan's law is the complement of the union of A and B equal to, the intersection of the complements of A and B. And of course, the second De Morgan's law is, the complement of A intersection B equal the complements, the union of the respective, the complement. Okay, now do you know you can be giving deal, sets, and they want you to find, to investigate the Morgan's law. Okay, now you have a U equal to this, and you have a B. This very U is more or less like a universal here. Okay, and we are A and B is expected to belong to U. So how do I investigate this? Of course, can it be so easy, right? And for us, here, found investigated union B, complement equal to that. So I'm going for do. What is a union B? Okay, the A union. So when I find A union B, so I have my A to be that, I have my B to be that, and of course, my A union B, when I combine that with that, my A union B equal to that. So if my A union B equal to that, I want to find the complement of this one. If I want to find the complement of this, then I will actually be referring to universal sets. I'm gonna go to the universal set. What are the elements in the universal set that are not in A union B? Please pay attention, okay? Whenever you want to find the complement of A union B, not relative to anything, but not relative to a particular set, but relative to the universal set. Okay, that's exactly what I mean. Okay, so what are the elements here now? Okay, what are the elements in the universal set? Okay, that are not in A union B. Okay, and the element is going to be 10 and 16. Okay, the elements here that are now here. Okay, so 10 and 16. Okay, that was why you have 10 and 16. So if this one is for this side, we also want to investigate for this side. Number one, we want to investigate what is the complement. The A complement is going to be what are the early numbers in the universal set, okay, that are not in A. Okay, it's 4, 10, 15, 16. What are the elements in the universal set that are not in B? Okay, 7, 10. Now, this is the complement of A, complement of B. Then what is the next thing I'm actually going to do? Okay, I need to find the intersection between them. So the intersection between them, I got 10 and 16. You can see they are equal. So which means the Morgan's theorem is already proved. Okay, so you can try the other one as well because of my time. You can try the other one. Okay, now I remember in class I did Cartesian products, right? Okay, so I have a set of A and a set of B. So A cross B, that's a Cartesian product. So 1 times 1, that's why I say 1 on B. Okay, 1 of that, then 5 on that and that and that. So that's how you see there. So A cross B and B cross A. So I think I work it to Cartesian product in class the other time. Okay, so and the proof of the Morgan's rule. Okay, the proof. I think I showed one of these yesterday, but I'm going to show you another way to show the first De Morgan's, how to prove the first De Morgan's law without giving any say. Okay, you can see here, I said if X come from here, if X is a member of that, S is a member of that, we indicate it's the same thing as, if S is from the complement of the union, then S, that implies S is not from the union of A and B. If X is from the complement of A union B, then another way to write that is that S is not from A union B. And if I split that, I'm automatically saying S does not belong to A and S does not belong to B. Because if S does not come from A union B, then S does not belong to A. S does not come from A and S does not come from B. And another way to write S does not come from is to change that. I can change that to S come from the complements of A. S come from the complement of B. And now when I say hand, okay, hand is going to lead to interception, and it's going to lead to interception, then I will say X belong to the complement of A, intersection complement of B. So that's another beautiful way to prove false De Morgan's law. So what if in exam? What if in assignment, if I may ask you to prove the second De Morgan's law? So this is the first De Morgan's law. Okay. Now the last question for today centered on this. You remember in class we talk about probability space, which is a triplet, the omega, the sample space, the coordinate set of event, and P, probability measure. Now they say show that for all set A1, A2, up to where A1, A2 lies in a coordinate. We want to show that the probability of the union is less or equal to the sum of the probability of AI. Okay, now this is a proof right here. You can define B1 to be A1, and if you for IE start from 1 to N, you're gonna see that all the BI, they're gonna be pairwise disjoint, okay? And if we write that guy equal to that automatically, we're gonna expect that, the probability of the union of AI up to AN, is gonna be equal to the probability of the union. Now, if you take a look at this, it's immediately say the probability associated with that are gonna be the same. And of course, the worst that's going to happen is, for the sum of the probability to be equal or that of B to be actually less. Okay, so this is all what I got for you. Of course, we're going to meet again on Monday. Is there any question before I go today? Is there any question? Okay, so until Monday that we're going to see again, make sure you all stay safe. This is being recorded. Of course, I'm also going to publish this on my YouTube channel. Okay, and of course, there's a possibility that, okay, I think a message came in. So come in, let me see what the message, the chat came in. When will the first work out? Of course, assignment, according to what I put in the syllabus, assignment will be published every Sunday, okay? And it's going to be due the following Sunday. So if you read the syllabus, okay, you're going to have the first assignments on Sunday. Let me do this. I'm going to stop my share, okay? I will advise that you all read syllabus from time to time. I'm going to do this now. I'm going to share my syllabus with everyone so that you can see what I just talked about. Now, this is the syllabus. Okay, this is Canvas. Okay, now I talk about, let me see, assignment. Can you see this? Assignment will be posted every Sunday night. Can you see the assignment submission policy? Assignment will be posted every Sunday night and will be doing the following Sunday. So assignment is always going to be released every Sunday and it's going to be due every Sunday. So for somebody who chat with me right now, I believe you send the information. This is on the canvas. Okay, so this is where I want to appreciate every one of you, for, oh, somebody raised up, okay, I thought somebody raised up his hand. So if there's no any other question, that is all what I got for you today. Make sure you all stay safe and have a lovely day. Bye for now, everyone. See you on Monday.
Thank you.
You're welcome.
See you Monday. Bye.
Bye. Take care, everyone.